If the function f of x is continuous at x equals 2, which of the following is true? Okay. We can do this. At least I hope so. Eesh. Okay. So we have derivative of x is positive for x is less than 2 and negative for... That makes no sense at all. No. Maybe. So continuous just means you can basically draw it with a straight line. That was terrible. Continuous means that you can draw it with your pencil without picking up your pencil. So it has nothing to do with positive or negative. So it's not this one. F of 2 equals limit of f of x as x approaches negative 2. So this is saying we have a graph like so. We have 2 right here. Probably should draw 1. And we have a graph like this. And it is saying that at this point right here, if it's continuous, then if we approach it from the left and if we approach it from the right, it'll be the same. And that'll be the same as what it actually is at 2. And I think that's correct. So I will circle this as a strong maybe. F of 2 is less than... No, makes no sense. Does that make sense? So what this is saying is you have a graph like this, and you have your graph, but there's a hole at 2, and then for some reason the actual value is down there. I don't know what that means. Nope, I'm going to say no. Derivative of f of x at 2 does not exist. Nope. If it's continuous, it's probably even more likely to have the derivative exist. And then this says this is the exact same as up here. So limit of f of x as approaches 2 minus. Okay. This one's kind of interesting. So this portion, x approaches 2 from the negative side of f of x equals limit as x approaches 2 plus of f of x. So what that's saying is the same as the previous one, where you approach it from the left, you approach it from the right, but it's not saying anything about the actual value of f of 2. So the difference between this one and that one is this one just includes that extra value, saying that that dot has to be in there. So when you're talking about a limit, so limit as x approaches 2 implies that the value from the left side and the right side are the same, but it doesn't say anything about the actual value f of 2. While continuous, you do have to have that f of 2 existing. So if you go back to the idea of you can draw f of x without picking up your pen, if you're doing this one right here, it'd be something like line, space, there, where that small hole doesn't have to exist. So right here would be 2 minus, right there would be 2 plus, but 2, well, we don't know. And so that's not continuous. Continuous would be something like this, where 2 does exist. So this is the correct answer right here. So if you look back at this problem, this talks about increasing, decreasing, has nothing to do with continuous. Derivative? No, it has nothing to do with derivative. The only two tricky ones are this option and this option is correct. And that's kind of how you deal with continuous functions.